Hi guys, this is Henry from the Singapore Center for 3D Printing, SC3DP. Today I'm going to show you some advanced electronic 3D printing in our center. So, what is a SC3DP? SC3DP is funded by the NRF Singapore and is located in NTU campus. In SC3DP, we have 7 pillars cater for the industry and the research need. As far as my presentation today is concerned, I'm more focused on electronic. The electronic I refer to not only a single line tracing, but we able to print layer by layer to form the whole PCB board. As shown in the diagram here, we're able to print the big or small scale of a PCB board. We're able to embed some coil or capacitor inside the board to increase the packaging density. And not only that, we're able to print flexible and transparent electronic that cater for your research and industry need. This diagram shows the significant size difference of our handphone from the 1980s to today. Few days ago, Apple just launched its iPhone 15. So this iPhone 15 is a very light with many functionality. If we sidetrack a bit to 1980, we will realize that our phone is very big and bulky, but their functionality is very limited. How can it be possible? It's due to the advancement in the chip semiconductor and also PCB industry that we're able to package as many as chip inside the one PCB board. So with this 3D printing technology, electronic 3D printing technology, we're able to increase the packaging density significantly. Later, I'm going to show you one by one. So what's so big deal of this electronic printing? So we know in the traditional PCB industry, the up to date, so the number of year that we can be printed is 16 years. So in the traditional industry, the PCB board need to go through the very tedious process. So after the engineer design the circuit, validate the circuit, they need to send the to the manufacturer to print it out, and this process will be through and for few times. And if somebody very familiar with this electronic industry, it's very hard for them to design some star shape or some fish shape or some other fancy shape in the traditional PCB industry. But with the advancement on electronic 3D printing, we can achieve it after you design it, when we can print it out. So somebody may ask, what's the limitation of this 3D electronic 3D printing? I would say the only limit in this technique is our imagination. Our imagination is only the limit to this 3D printing, electronic 3D printing. So I urge everyone, come to us, contact the SC3DP to visit us. You know? We will explore all the possibilities together. Together with our collaborator from the School of Electronics, we are to explore the possibility to place multiple IC chip in the one location, because we want to increase the packaging density significantly. As I mentioned, in the current use of technology, we're not able to pack many IC chip in a one single location. But with this 3D printer, we're able to do it. Just a matter of our imagination, matter of strength. So I'm quite sure this technology is a disruptive technology, it's a game changer technology. So I hope those working in the industry, please visit SC3DP, and together with I myself, our business team, and also executive writer, we can explore all the possibilities together and bring your business need to the new high. Here, I'm going to show you our first case study that is printed in SC3DP, which is a step-up transformer. Okay, we are designing the 4 LED which connect in CD, and this LED is a high power LED, and they require 5 volt to power it up. Okay, they connect in CD, so we need 20 volt. But we also know the input voltage from the USB only 5 volt, so there are no way to power up without any transfer. So in this case study, we embedded 20 tons of induction coil embedded inside this PCB to power up the voltage from 5 volt to 20 volt to turn this 4 LED up. Of course, somebody may say we can use a traditional step-up converter or step-up transformer to do it. Well, but we need additional circuit and it's very bulky. So in this study, also show us we are very confident by somebody design our component, we're able to increase our packaging density to meet your business need. Next, just now we also mentioned the capacitor. Capacitor play a significant role in the PCB board. In each PCB board, we can see a number of very huge capacitor, and they are occupied. They occupy many space. So can we do something of it? Yes, we know. For the electronic band now, we know capacitor is governed by this formula: external naught, external R, which is light electric constant of a material, times A over distance. Distance is the distance between the two conductor plate. So we can smartly design the finger shape, then to embed this capacitor inside the board. So here we design 20 layers of capacitor, sandwich together. They connect in parallel, and on top, because we want to form the circuit, we put the inductor there. So capacitor and inductor, we form the low pass filter, and this low pass filter has been tested in our collaborator. It's working very well. So with this fundamental know-how, we further elaborate our technology. We push our know-how to the limit. So we print 55 layer capacitor, and we not only print it, but we integrate with into the circuit, into the functional circuit. So you can see at the right hand side, we're able to use this capacitor as a timer and to turn the LED light up, light off, light up, depend on their charging and discharging effect. Other than the embedded the coil into the PCB, capacitor into the PCB, is there anything else we can do to increase the packaging density? Yes. Can we put the component at the side? The answer is yes. But in the traditional or current use of PCB technology, we can't at all. We only can put the component at the front or at the back. Can we put it aside? Very challenging. Okay. But with this technology, with this 3D printing technology, we can put the component mounted at the side. So by putting the component on the top, on the back, at the side, actually we can increase the functional the packaging density significantly, and also we can integrate, by smartly design some component to integrate this whole PCB as a system. Okay, as a system, and we also can put some connector at the side, so at our board or our PCB board, so it can slot in into the PCB or into our PC or our CPU or data processor immediately after we print it out. So you can see how excellent of this technology, how amazing of this technology. So this technology, just for information, in Singapore, we are the only one have such technology till now. So I urge everyone, come to visit us, SC3DP, and we're going to discuss all possibilities together. And I hope after your discussion, we can work together and bring your research need to the new high, your business to the new high. Okay. And for those working on biosensor, we also know that biosensing is after you put a specimen on the test kit, we need to embed a lot of electronic components such as amplifier, processor, transducer to enable it to differentiate the test data, the test specimen and our specimen. So can we simplify it? Yes, by this 3D printing, actually, we not only can design the shape of a test kit, but we can embed some of a circuit inside. So after we print out, and you put your specimen, test sample, control sample, and the test sample inside, so you can plug your biosensor into the data logger to read it out. Just a minute of time. So next, our collaborator have designed something called wireless battery charger. So what's the function of this board is we're going to introduce the microwave signal or inductor signal to the inductance coin here, and this inductance coin controlled by the microprocessor, we're able to charge the battery. We could use, in other words, we use a microwave signal to charge our capacitor wirelessly. Okay. The beauty of this technology is we're able to make the cavity. You can see the diagram at the center is a cavity. So it's about 1 centimeter deep cavity. So in this cavity, we're able to place the our battery over there. In the current use of PCB technology, it's very hard for us to drill a hole evenly throughout the entire surface. But with this technology, we can do it simply just a few clips. So I mean that's why I think from the beginning of my presentation to the end, I would say this technology is a game changer technology for those working in the research and in the electronic industry. That's all for my presentation. Thank you very much. Okay, I would really welcome everyone to visit the SC3DP, to visit us, to understand what is electronic printing, and hopefully everybody can tap on these game changers technology to propel their research and business need to new height. Thank you very much. See you guys in SC3DP very soon. Thank you.